The following results were obtained from an experiment performed on a spiral spring. We have a stretch force and the values are this. We have extension and the values are this. And we're asked to determine slope. So to determine slope, we first of all plot a graph of force against extension. So we're going to draw the two axes, force in brackets Newton. In the same way, we put an arrow here and write extension in brackets cm. First thing we are going to do is to choose a suitable scale. Looking at this, we have 1, 2, 3, 4, 5, 6. So which means the highest number here is 6, while 0 stands in as the origin. So we go. Here is 0. Call here 1, 2, 3, 4, 5, and here is 6. So for extension, 0 is the origin, while the highest number is 30. So we now come over to here, and right here will be, if we say 5, 10, 15, 20, 25, 30. Okay, so we say 5, here becomes 10, 15, 20, 25, 30, 35, 40, and 45. So we can now plot. First, we have 0 against 0, so we mark the axes at this point. Then the next is 1 against 5. So this is 1, while here is 5. So we mark our axes here. The next is 2 against 10. So here is 2, while here is 10. So we mark the axes here. The next is 3 against 15. Here is 3, here is 15. So we mark axes here. Then the next is 4 against 20. 4 against 20. Here is 4, while here is 20. So I'll mark my axes here. The next is 5 against 25. So this is 5, while here is 25. I will take it up. Now mark the axes here. While the last is 6 against 30. So this is 6. So I'll look for 30. Here is the meeting point. So I'll mark my axes here. So I've succeeded in plotting this. Remember, in plotting graph, you first of all draw the axis. Ensure you label the axis. Then the next is for you to choose a suitable scale. You choose a scale to ensure that the plotting covers at least 1/3 of the graph sheet. So the next thing we are going to do is to determine the slope. But before we determine slope, we draw a line of best fit. A line of best fit is simply a straight line that covers 1/3 of the plotting. Looking at this, this is a straight line graph that passes through the origin. So this is my line of best fit. Then we're asked to determine slope. To determine slope, you draw a right angle triangle from any point of your choice. This is the right angle triangle. So I'm going to join it here. Ensure that your right angle triangle is big. Then I'll come here and write change in force, change in extension. So let's calculate slope. Slope will be equal to change in F over change in E. That is F2 minus F1 all over E2 minus E1. Let's find the value of F2. F2 is this very point. So here is 6. So So I'll write 6 minus, what is F1? Here is F1, here is 1, here is 2. So the midpoint is 1.5. So here is equal to 1.5 over, we now find the value of E2. E2 is here, which is 30. So I'll write 30 here, minus, here is 5. The next box is 5.5, 6.0, 6.5, 7.0, 7.5. So I will write 7.5. So I will subtract 6 minus 1.5 is equal to 4.5 over 30 minus 7.5 is equal to 22.5. So let's divide 4.5 by 22.5. Answer is 0.2. So 0.2 is the slope. Going for the next question says, what does the slope of the graph represent? What does this slope represent? One thing you should know is that this is a graph of force against extension. And force against extension talks about Hooke's law. Force, removing the constant of proportionality, we are going to have K, E. K represents force constant or elastic stiffness. So if we make K the subject of the formula, we are going to have force over extension, which is this. So therefore, the slope of the graph represents force constant or elastic stiffness. Bye.